Hey, fellas.
Hi.
No.
Paige, you are going to be the only student in Chippewa. Is that going to be okay with you?
Yeah.
You're the lonely little petunia. Atch.
Lucky me.
Lucky you. Lucky me, she says. Okay, it'll take me just a couple minutes. I got to get some stuff set up here. This is college algebra, and some folks did not get their books yet. Can you raise your hand if that is you? Okay, and my guess is you won't be able to get them, what did they say, Felicia, till Monday next week? So until then, you'll have to get them through my math lab, but we're going to talk about that in a few minutes. Right now we're going to start with a experiment as soon as I get the computer going here.
Yeah, no. I thought you were going to take my name today.
All right. If you do have a book, open it up to the first page. If you don't have a book and you do have your computer, let's do this. Since there's a number of people that don't have their book, if you do have a Pearson account, just go to my math lab. Do any of the folks that have never used Pearson before have a computer? Raise your hand. Okay, so in Menominee, would you guys mind watching Eric? Oh, you have a Pearson account? Okay, I'm going to show you how to get there. Eric, did you already log in to my math lab for the college algebra?
No, I still have the intermediate notes.
Okay, so if you guys in Menominee watch Eric's computer page, did you log in yet?
I am getting my internet hooked up.
You did what?
I'm getting my internet connected right now. And then I will.
Oh, okay. So you have confidence that you know what you're doing? Bailey, can you sit next to Jess and then help her get... Oh, I'm sorry. I thought that was her. Can you watch Bailey's computer and then see how it's done? Laura, can you watch Felicia's computer? Yes.
Okay, so how do I get it so it's like more classes? So I'm having like what we
We're getting... I'm going to show... Did this turn off? Let's turn that on. And you kick him over the... Okay, so in my math lab, If you already have an account, click the sign in. If you don't have an account, click the register now. Okay, so this is the class that you're going to be signing up for. Hulky 37292. Write that number down someplace because everybody has to register to that account. Oops, I should have told you to bring your stuff over. 37292. So there is one person that was already enrolled. But anyway, here's what you do. If you do not have this account, let me think. Did I make a mistake here? Where do you do the sign in? Is there a enroll in a course button on your?
Yeah, but yeah, got it.
Okay, so enroll in a course. I don't see that button on mine. What am I?
Yeah, it is. Isn't it enroll as a section structure that looks just like ours?
Oh, okay.
Create copy. That's the.
Here's where you enter your course ID, Hulky 37292. All right. The reason why it's important to get in there, and then, you do not need to pay now. You can pay within 14 days. I see Eric's entering his code. Connor's entering his code. Nicole, you okay?
Yeah, it just it's loading.
It's loading.
I have a really slow laptop.
Jess, Janae, you're good?
So actually,
Can I? So if you want the 14 days free, can you see Felicia's computer? If you click right underneath where the 4 different books are, there's a little button there that says register for 14 days free. You can get that. I'll show you what it looks like in a different course, okay? I'll show you the picture. Underneath where you see the 4 things, you could put your access code in here, but it says get temporary access code without payment for 14 days. You can click on that now if you don't have your code here today. The reason that this is so important is there is a textbook in So I'm gonna log into our course. Inside our course, so I'm gonna click on our course, and inside there, under student materials to print, there's a in-class student notebook, and if you click on that, you will have the entire textbook. So there are some folks that just print that off, and then they don't have to buy it from the bookstore. But we are on page 1 of that book. I'm going to quit talking so you can make sure that you know what you're doing in Pearson. So go, start talking.
You know what you're doing?
Yeah.
Probably still have to pay for all the paper.
Oh, did you buy it?
No, I haven't bought it. That stuff at Oak Ridge.
Yeah.
Wait, where was?
In case you'd be safe.
Yeah.
So,
Student.
It's like our computers forgot everything they know.
I'm literally doing it all after this stuff. We're the first ones to present.
any question, just tell me. Couldn't remember.
We don't even have a paragraph. We got a layout. So we got. And we're the first ones to present. Oh, excited.
Yeah. Like for the last.
Yeah, you know it.
You didn't go right looking over something. I don't remember any of this. Framed it all.
Finish that sheet then.
The study guide?
Yeah.
I feel like in the back there are like 2 or 3 sections we have to go over. But we might have. It's,
I don't know what's happening.
it's like the last one was basically in your notes and it was like really easy to find. Some of these.
Okay, I'm going to take attendance. Nick. Michael.
Yep.
Marlena.
Yep.
Gavin. Janae. Felicia. Nicole. Eric.
Here.
Rachel. Philip.
Yeah.
Grant.
Yep.
Connor. Paige.
Here.
Eric. Laura. Maddie. Sarah. Bailey. Jessica. Lauren. Oh, that's right. She's going to be gone this week. Jake. Chris. And Sam. All right. On page 1 of our textbook, if you've got the printed version, you can open it up to page 1. No, some of you that had intermediate algebra, can you help out the people who are new to the way that Dana Center does stuff as to whether you need the textbook or not? Is it a good idea? So you have some place to write stuff?
I'd say so. But if you don't want to pay for it, and it's like you're scraping away the money, don't do it. It's fine. You can just take notes in class.
Yeah, but like Maddie said, if you are going to not have the textbook, make sure you bring papers that you can take notes and stuff like that. So when you get home, you're going to open this up because the secret code, the $1 million code, is in this book. It is more precious than fine ointment. All right. You are playing with a tennis ball in your backyard. You hit the ball straight up in the air and watch it until it falls to the ground. As you watch the ball rise and fall, you think about some of the quantities associated with these situations and how these quantities are changing. The difference between this course and any other course you've had before is we spend tons of time talking about changing. So, would you please, Jake, for us, stand up and throw the ball up in the air and catch it? Pretty easy stuff, right? So we're going to think about that now. He's going to throw the ball up in the air and catch it over this detector. So this might take a little practice because you have to make sure that you're over the detector. No, not you is over the detector. The ball is over the detector. Okay, so when you hear it click, let her rip. You ready? No, it didn't click yet. Now it did. Okay, let's try it. Why don't you get on your hands and knees and try it closer to the detector because you lost it there a little bit. You ready? Now wait till you hear it click. Okay, it was good on the way up, not so good on the way down. You see what happened is that it lost it right here. Everybody agree with what happened? Okay, so he's going to try it again. Not too bad. I like that one. Okay. Now, do you want to try another one just so that we can make sure it's there the whole? Now, I think what happened. I think what happened is right here, it detected your hand. So when you throw it up, could you go like this? Throw it up, get your hands out of the way, and then come underneath it and grab it.
Sure.
No, it's okay if you let it fall. The problem is.
Don't let it hit that.
Yeah.
Got it. Get my hands out of the way.
Menominee, can you guys see him okay there in the front of the room? Tell you what, why don't you turn around to the other side so that everybody can see you and see the ball in motion? Oh, almost perfect. Do you see what happened that time? Just for a split second, the ball got out of the way. Okay? That's good enough, I think. I want to labor the point. Thank you very much. Oh, yes. Our ball. Not going to do anything with this graph right now, but before we get started discussing it as a team, let's answer these questions on it for ourselves. List 3 or 4 quantities that are related to this scenario. What units might be used to measure these quantities? So think about it and write them down. So I was just pleased this morning. Underneath my chair in the family room, I found a purple pen. Remember how my purple pen ran out of ink? I was just so happy. The lost has been found. Okay, quantities and units. Let's hear them.
Weight, which would probably be in grams.
Did anybody have any other ones?
Gravity.
No, I meant any other units for height first. Okay, so everybody agree it could be in inches, in feet, or in meters. Okay, what did you have for units for gravity?
Meters
That's
per
it.
second. isn't it?
Very, very good. Meters per second. You're probably a physics student if you know the answer to this one.
Square.
Squared. Yeah,
Yeah.
meters per second squared.
Velocity.
Meters per second. Okay? Everybody good with that? Are there any others that anybody had?
Air resistance.
Oh, good one. And what did you have for a unit for that?
I didn't have one. I couldn't think of one.
What does the capital N stand for?
Newtons.
Newtons. Very good. Okay. A little bit of physics and calculus tells us that the tennis ball thrown straight up with a certain speed than the height above the ground measured in meters after t seconds is given by the following equation. Before we go to the equation, I'm going to go back to the graph here. Oops, that's not the graph. I'm going to go back to the graph here and notice it gives us two different graphs. Okay, let's sketch those two different graphs on our paper. The top one, now you guys didn't call it position, you called it, Sarah, I think you were the one that said it, height, or yeah, height, okay? And notice the height that they gave is in meters. Now somebody who said height said it could be in inches or feet, but right now the device that we used is set for meters just because it is, okay? So don't sketch the whole graph. Let's just sketch the part from where it starts going up and just pretend like it didn't go off the screen for that little bit, and so just continue it down again. So, I mean, it's okay if you sketch the whole thing. But the important part to consider is just that hump. Ooh, here's a good question to know if you know anything about algebra already. What shape is that hump?
Parabola.
Very good. Parabola. You can write it down if you didn't know it. It's a parabola. Okay? And then for the other graph, it says it's velocity. Jake, did you or did you not throw the ball straight up in the air?
I did.
If the ball went straight up in the air and went straight back down, why does the graph make it look like he threw it kind of like, a baseball player hits the ball? It goes up in the air and then it comes back down. Why does it look like that when he threw it straight up and it came straight back down? Okay, so the distance is the up and down axis, right? But the crosswise axis is not distance. The crosswise axis is time, okay? So it's measuring two quantities, but it's not the quantity of, like, the baseball player that hits the home run that beats the Brewers who get to go home for the rest of the season. I'm not saying I'm bitter or anything like that. But why did they put him into the game? Why didn't they put Woodruff in? Jeffers, he's not a bad pitcher, but I don't know. Whatever. I'll let it go. No, I won't. Okay, so you understand that it's showing time and height. I've got another couple graphs to show you that I think will help us with this situation. Let's see here. Here's one of them. So this is a kid out throwing a soccer ball. It goes straight up in the air, comes straight back down. Well, I had my grandson. Oops, I better stop that video, otherwise it'll go on to the world's largest giraffe or something like that.
Hi, it's Kip King back with another weekend project from the pages of May.
Yeah, compressed air rocket. Well, okay. I have another. Nope, that's not the one. Just wait. That's not it either. Oh, come on now, Kevin. Where is it? Oh, I know. Okay, so here's that same thing that Jake did, only they have a good graph of it. Okay? Now, obviously, this was not their first attempt because you saw how difficult it was to get stuff to work out right. But the other thing that you notice is Jake's graph went all the way up to 2 meters, and hers only goes up to 1 meter. So when she throws the ball here, you're going to see what happens when she throws it. She's only going to throw it a little distance, okay? It's going to go up and come back down, okay? So, let's see, where do we start? Oh, there it is, start. Got it? See what's happening? So she throws it up, it comes back down. Okay, and then I also did the one where I had so on this is that video of the guy throwing the soccer ball up into the air. And what I did is I had Uriah make each one of these little dots here, so as the video was playing, it would stop every time. And then he would click on where the ball was. This was back when he was in 2nd grade. And I think what happened here is either the video stopped, because you notice how there's 3 dots right in one spot, and it looks like it's kind of spread out there, like some dots are missing. Either that happened or Uriah missed the ball for those 3 spots. But I'm gonna play it for you so you see. Where did the play button go? Oh, there it is. So you see what happened here at the beginning? Why did the ball go down and then up?
Because he dipped.
Yeah, because he had the ball, he went down, and then he threw it in the air. Are you with me? Okay? And then what happened here at the end? He didn't catch it.
It bounced.
It bounced. Yeah, the ball hit the ground, and then it bounced up. You see what happened? But in all 3 cases, what do we have for what happened with the ball?
It arced.
It arced, right? And the arc was because we had time this way and height this way. Got it? So when we see graphs like this, that's the situation that we have. Now, I'm going to sketch all 3 of those in my notes. Oops. Sorry about that. This is Jake. Okay. This is soccer ball. And would you be okay if I just called this one the girl? Because I don't know what else. Ooh, you can't see that. Sometimes my video freezes, so when you see that happening, if you see me writing and you see nothing happening there, let me know. I think the computer its brain gets full, and plus it's Monday. Okay. Each one of those three has a different formula that goes with it. I'm going to show you Jake's toss again, and we're going to find the formula for when he tossed it. And I'm going to start, I should start here. I'm not going to do the whole thing. I'm only going to do a good section. Okay, and then it will be able to figure out a formula for that when I press the button, figure out a formula. Analyze, curve fit, and we're going to do the quadratic. So on our notes, not only do we call this a parabola, but we call the equation a quadratic. And I don't know why they call it quadratic, because the quad part means 4 in my mind, right? But you'll see what the formula comes up when we write the formula. Oops. So let's go back here to Jake's formula. I'm going to try fit. And if you notice, it shows the black line is the formula it came up with for Jake's toss. You see that? And the formula, can you guys read those numbers okay for A, B, and C?
Yeah.
Okay, so here we go. H of t equals negative 4.8 t squared plus 12.71 t minus 6. So that's Jake's formula. Then we're going to go to the soccer ball. That's this one here. And here we would write h of t equals negative 0.11 t squared plus 1.5 t minus 5.6. And then let's go to the third one. And we don't have a curve fit yet, so we can take her whole graph just about, analyze, curve fit. It's a quadratic, try fit, okie dokie. And hers is h of t equals negative 4.7 t squared plus 9.5 t minus 3.8. So do your notes look like that? What is the key that you can see from these formulas that tells you it's a quadratic? Oh, very good. I'm going to highlight it. Now, the first one and the last one pretty much have the same, what do you call a number in front of a letter? The same coefficient, right? The first one has a coefficient of negative 4.8. The last one has a coefficient of negative 4.7. Everybody okay with that? You see those two things? So the coefficient here is negative 4.8. The coefficient down here is negative 4.7. Anybody want to speculate why the middle one has such a strange coefficient compared to the other ones? Well, it wasn't doing it full scale, right? It was doing it on a computer screen. So in other words, when the ball on your screen was thrown up into the air, it went this high, but that's this high on your screen. In real life, it went way higher than that, okay? So it wasn't totally to scale. Just a question. Compare Jake to the girl. Does anybody want to speculate on why, from the equation, why Jake's ball went higher in the air than the girl's ball did? From the equation. It's okay if you don't. We're going to learn that that second number tells us how fast the ball was thrown. Jake threw the ball at 12 meters per second. She threw the ball at 9 meters per second. So his ball went higher in the air than her ball did. Okay? That's the only difference between those two. Textbook. Page 1, here at the bottom. Here is the formula that they say. H equals negative 4.9 t squared plus 20t. So let's write that formula down on our notes. H equals negative 4.9 t squared plus 20t. And let's sketch a parabola for it also, because we know that if we're going to graph it, it's going to look like those parabolas that we've drawn before. Okay, next. We are going to use a computer program called Desmos to make graphs in this class. If you have your phone, on your phone, where'd my glasses go? They're there. On your phone, go to the App Store. And type Desmos. Notice dating app came up there right away. Curious why it thought I needed a date. I don't think Sandy would approve. Okay, so I've already got Desmos installed on my phone, but if you do not have Desmos on your phone or on your computer, please download it now, because we're going to be using that throughout the class. Do you have your phone here today or not?
Yeah, it's not compatible.
Wait, Desmos works on iPhones, doesn't it, you guys? Oh, that's not an iPhone?
No.
Oh, with this version, go back to the Play Store and see if you can. What is that? Is that a 4?
Old and cheap.
Old and cheap. I don't know. Do you have a tablet or a laptop that you can bring to class?
Yeah.
Okay, I can bring that tomorrow. Menominee, you guys okay?
Yep.
Paige, yours is working?
Yep.
Okay, so I'm going to go to the internet version for the computer, because well, there's a couple reasons. I'll tell you the one. One of them is I shake severely. I don't have Parkinson's disease. I've got something else that I'm not sure what it is. But I can't, like, do phones. I don't even know why I have one. It's just dumb. So I don't use the phone version. I use the internet version. But I'm going to go to Desmos and I'm going to, I'll just start a new page. So on this page, I'm going to make a graph, and then I'm going to write h equals negative 4.9 t, and then the that is, you can use your keyboard for the that, it's right here. T squared, I forgot what it was, plus 20t. Plus 20t. And when I get done, it shows me the graph, but the graph is out of focus. If you haven't used Desmos before and you have questions, make sure you ask somebody so they can show you how this works, okay? So then in the wrench, I don't need the x-axis to go from negative 10 to positive 10. I only need it to start at 0 because time starts at 0. And it looks like if I go to 5 seconds, that'll be time enough. So you can see that my graph works the whole distance that way. But I need to change the y. I can start at 0, and let's say I went up to 20. Would that be high enough? Nope, not quite. Let's go to 25. So if I go to 25, I get the whole graph to appear on my screen. Okay? Everybody good? Gavin, you got it? Yeah. It's appearing? So what I wanted to show you is that this equation here has meaning. But what I really wanted to show you is, remember how we were talking about that this class talks about change? I'm going to go back here and I'm going to show you what we mean by how the graph changes. Do you notice that I have it so that it's showing the ball going up into the air, and towards the top it gets really, really slow and then it speeds up on the way down? So what it's showing you is that for every time, there's a position for the ball. Right? Those two things work together. This graph is like a explanation of what's happening in real life. All right? Page 2. With the people at your table, see if you can figure out mathematically how to write each of those different things, A, B, C, D, E, and F. Right? So write them in your book or write them on your notes, and we will go through them when you've got it done. Okay? Go. You might want to use your calculator to answer some of these questions. Or you could use your Desmos graph to answer these questions. Either one of them will give you the answers. Anybody need some help? Let's do number one, or letter A, just so that everybody's on the right page. What did you get for an answer for letter A? Anybody get an answer? 15.1 is the numerical part of the answer. 15.1, what is H? Meters. How did you get that, Eric?
I went in Desmos.
Okay, so in Desmos, he went into Desmos, and?
I went to the 1 second mark and you have 15.1.
You see what he did? Everybody see that? So he clicked on the graph at 1 second, and it was 15.1. Did anybody do it on their calculator? Let's take out our calculators and let's do it there. We got it in there someplace. There it is. What'd you do on your calculator? Negative 4.9 times. Have you heard of substitution? Right? We're going to take the formula that we had on the previous page. Do you need a calculator?
No, I'm good.
Okay. And what? Put in 1 squared, right? Because that's our first time. Then what? Plus, I forgot what it was, 20? 20 times 1. And we get 15.1. Okay? Does that help you? So we would say negative 4.9 times 1 squared plus 20 times 1, which is 15.1. Got it? Confidence level on doing B, C, D, E, and F. So I've got 5 fingers. 5 is I'm really confident. 1 is I'm not very confident at all. Let's see some fingers. Go. Ooh, 1, Maddie. Looks like you're going to need some help. Marlena can help you. Okay? 4 only. Sarah, try it and compare your answers with Bailey and Jess because it looks like they're okay. Felicia, you're okay? All right. Go. Get them done. I'll make this full size again so that you can see the answer or see the questions.
See? It's just.
So what are you pressing, Madeline?
I'm just putting in 2 for that one.
Okay, so you're higher than 1.
That's what I got.
Yep.
Awesome.
Ask her if that's what she got.
Sweet.
Are you held up on C though, huh?
No, I just didn't get that far.
Oh, okay.
Yeah, I'm going to be too.
So what did you do for the other ones? Whatever they gave you, you just substituted it in. So give me the formula and substitute it in. Negative 4.9 T squared plus. Got it? Okay.
Change the x.
D, change in height. between 1 and 2 seconds. Because remember, I told you this class is going to be dealing with change.
What did you get?
For what? There's equations.
Oh, are you serious?
Yeah, because it would be like any code. You could draw any number.
Oh, why gave me a negative 54? Okay. Yes.
What? D. Anybody get a good answer? What'd you get?
F of 1 minus F of 2.
Okay. Do you have an exact value? Did anybody get an exact value?
5.3.
Positive 5. How did they get it? What's the change between... Change means subtract. What are we going to subtract? The second value, 20.1, that's what we got for 2 seconds, minus the first value, 15.1, that's the amount that we got for 1 second, right? 20.1 minus 15.1 is 5. E. Do you see that for E? You have to do some math to figure this out. What do you have to do? Substitute in 2.5 and figure what number you get. Substitute in 1.5 and figure out what you get. And do what with those two answers? Subtract them. Okay, so that's the math that you have for E. The math for F, I'll write the math for F and you see if you understand what it means. For F, it says you take the second height, which is negative 4.9 times the second t squared plus 20 times the second t. That's our first thing. And then we're going to subtract our second thing, our first thing, which is negative 4.9 times T1 squared plus 20 times T1. Okay, so now do E and tell me the answer. So when I did it in Desmos, what did I get for the height at 2.5 seconds? How much? 19.375. So that's my second height, right? Minus my first height. What was the first height? 18.975. And when I do that subtraction, how much did the height change between 1.5 seconds and 2.5 seconds? 0.4 meters. Is that what everybody got? When you did the math, Sarah, you okay? All right. Talk it over for just a few seconds so that we can make sure we got all of those answers right.
Well, use the
Okay, we will take our break. When we come back, it will be 1 minute after 10.
We didn't have any homework. Really should have brought food.
What program are you guys in?
Liberal arts.
Business. No.
What year?
Just
Sure. So you guys graduated high school last year? Like kind of, sort of. I'll be a junior by the time I'm done this fall. I start at Eau Claire in the spring. Let's see. Did all my general credits here that I could. Saved a ton of money.
So much this one, but so room I had it in this one into the room with it. They were having
I mean, I have no clue. That's what I did. That's what you get like that. Unless I'm doing something wrong. I spent the whole time doing
An expensive one.
Yeah, what expensive?
I have a color display.
Nice.
any questions you
Yeah,
ask.
it's beautiful.
Yeah, it
I
is.
love it.
Good. Sitting here.
How much was it, don't mind me asking?
Overall, it's not, but it's on the
You're exhausted. I'll even ask you that.
like that's
Oh, yeah. Everyone.
Wait, it's
Alright, what one do you have?
Thanks.
Inspire Casio.
Yeah, I just got a newer one of these. It's got the lit screen and it's got a rechargeable battery.
the seconds or?
Just my sixth class, the teacher said you should get it. Yeah, it's pretty similar.
Where is it?
Not quite.
How it operates too is different.
Yeah.
Like but there are variables and stuff like that, but I don't understand.
Look at here, I can insert stuff. So
So you just write the equations. Yeah.
probability statistics, matrices. Ridiculously awesome.
Yeah, I bought mine used.
So then you know.
Wait, no, it really
It is. Saved myself like $50. Is our homework due every like Sunday night?
They say, hey,
Basically, yeah.
go ahead and work this week.
Do it every Monday.
Monday night?
Monday night, it's due every Monday night.
Monday or
Sunday
Sunday?
night.
Hey, I was just gonna
Usually, that's.
Menominee, is your printer on? Because I just set something to print there.
That's usually always on. It's good.
It's coming up. Good.
I think you took you fish.
You have to attend class.
So I just want to turn it down. I feel like I wanted him to win.
Okay, so Rachel,
Yes, the syllabus.
Chris.
I don't think so. Maybe.
I know.
Connor, why don't you be in this group?
Sounds like he's taken some of his classes. Seems like a pretty cool dude.
Yeah.
You guys can take Lauren, okay, when she comes next time. She won't be here till Tuesday though. And then you guys will have Chris, okay? So you guys are one group of 5. This set of tables. You guys are good. You guys will be good. Connor, are you going to move over here, Brian? Okay. Otherwise, we can just pull the table over.
This is what we did before.
I guess the Austin.
Yeah.
This guy just took.
I'm gonna write in yellow so nobody can see it.
Yeah, I mean, it's just college algebra. That's cool.
You kind of feel these on test.
I have statistics. That's for part of class.
Oh, it's my taking like.
Yeah, it's not so bad. There's so much homework.
I think the AP.
Okay.
Cats and dogs.
Did you just graduate last year too? Just graduate last year.
You know what the desired outcome are, anyways.
You taking
in
it
Pleasant.
for this
And the first thing I saw was my
I've been taking everything
Science
online.
Center, which is right to learn,
Transfer to
stress,
Twitter.
anxiety, fear of failure.
So
Okay.
Stigmatize failure.
once I'm done with my fall
You
class,
make a
I'll-
mistake as a student, you lose a point. Therefore, students become risk averse. Better not take any risk. Well, you're never going to be innovators.
Can you guys hear that okay on your campuses?
So in a
If you
certain
can't, you're going to
sense,
have to
our
turn up
approach to
volume.
assessment and the grading in particular makes our students risk averse and therefore stifles creativity and innovation in the brain. I'm going to switch here and show you a picture which needs no explanation. You saw right away what this picture represents. And if this picture evokes any pleasant memories, then I'd like to talk to you in the break. What are some of the feelings that come to mind when you see this picture? Anxiety, stress, what else? Fear of failure. Pardon me? Very good. Isolation. Yes, that's exactly what I was actually after, because very good. All those other words that we heard,
Eric
by the way,
teaches at
aren't
Harvard.
they incredibly conducive to learning, stress, anxiety, fear of failure. But isolation is what I really wanted to get at. Look at this picture. They're cut off from each other and cut off from any source of information. You know, I read in the New York Times a few months ago that now when you take the SAT, you have to even take off your watch. It won't take long because students have to take the exams naked. Now, ask yourselves, things since you took your last exam, whatever that may have been, have you ever been put in a situation like that one there where you are cut off from any other human being and cut off from any source of information? Can you think of any occasion on which that has happened in your professional life? No. I mean, when I write a paper on nanophotonics, which is my field of research, I can look up whatever I want, whenever I want it, and consult anybody I want, whenever I want it. When I'm sitting in my office writing this paper, there's not somebody standing next to me saying, you're not...
So one of the things that we have in this book that might be different than other courses that you've taken is they strongly are proponents of, let's go to section 2 and we're going to come back, or section B, and we're going to come back to section 1 and finish it, is that we are going to be talking about a learning community. We function best as people when we work with other folks. Math, we want to do the same way. It helps us, or it helps many people succeed. A situation that I had, so I first started using this, probably 20 years ago, and I had 2 people in my class. One of them, when she heard that they were going to be doing group work, said, oh, this is going to be so fun because I'm never really sure of my answers. And this other guy says, I hate this. People are just going to use all my work, and I'm going to be just teaching other people stuff. Okay? Those 2 are now happily married to each other, and they have like 4 kids. So I think it's interesting how life works out for people. So, in order to get started down this road, I passed out to each one of you a slip of paper called Small Group, where'd it go? Called Small Group Contact Information. On that piece of paper, write down your name and your contact information, which would probably be your phone number or your email address. And when you get done, hand it to the next person in your group, and they will put down their information on that piece of paper. And so by the time you get around one time, there should be 4 people's information on your sheet that you have, okay? Go. Start writing. Paige, you can fill in all 4 blanks with your information, okay? Did you get my email about the videos? Is that going to be helpful to you? Or did you get that email?
No. Did you send it
Okay,
recently?
I sent you an email on Saturday or Sunday about that there's videos available. You might want to check your email and see if that's going to work for you.
All right, I'll check it.
Yep.
Yes. It was only a little bit. Yeah, it was only a little bit. I mean, but you know, in case there's anything. It's been
That one, right? I was. Yeah, because there's part of that.
Why?
Everybody got their sheets filled out? On the back side. Now, Menominee, this probably isn't going to be a lot of fun for you because you've only got enough for one group. So, Claire, here's what you're going to do. Common pairs. Each pair must be with a different person, and we're going to rate the characteristic that combines with that person, or that connects with that person. So what we're going to do now is, at least in Eau Claire, although Menominee and Chippewa, you can do it too, is we are going to find somebody not in our group with whom we share a hobby, share something about work, share something about family, share something about school. So we're going to have 4 different people, all of them not on our table, that we are going to write their names down for. Nicole, Felicia, you gotta think of something, okay? Everybody ready? So, stand up, take your seat, and then when you find that person, have them write their information under the contact. Go!
Have all your guys' contact, so. What's your guys' hobbies? Music.
I trade in stock.
If you like to watch, like to hunt or like to fish. You guys go. Write it down.
Family? I have a family. All right. Yeah, family. What do you do? Never mind.
You guys work?
That's weird how that works.
I had 2 jobs and then now that I moved to Menominee.
Yeah. Okay, I would rather do
I work for birds.
I don't want
Do you work at Menards? I work there. Accounting buildings.
What do you need?
1, 2, and 3. Smartation.
Yeah. And then 715.
Instagram.
No. Used to.
Working with that.
Just write his contact information. That's what we did. Oh. We're not doing work. I thought we did. I did it. That's what we did in the last interview. Okay. Awesome.
So everyone here is what? 18? 19? 18?
Yeah, we both go to CBT.
Anybody still have problems?
December 13th? Ooh, you're 5 days older than me.
Thanks.
You guys are also young. Just turned 22.
22.
Alright, good job.
Actually,
That's
How you doing?
You watch that?
Everybody good?
Uh,
Today,
20, 30 minutes. It's like 20 minutes north of here.
Okay.
I work. That could be good enough. You don't have to be
I work
like.
full time in a machine shop with it.
It could be as simple as I know what work is.
I actually went and got my machine tooling for a tech.
I don't know what work is.
business.
Not make it difficult.
I work night shift, so I'll be up until about 1 a.m.
Yes, my number is 5-1.
Talk to my managers or my supervisors and be like, not stay till 1 and stay till midnight.
Everybody ready?
I just have a half-hour drive. When I worked in
Okay, next. Chippewa and Menominee,
I don't know what time
you
it
have
was.
to
It's
come
been
and
3 in the morning.
stand close to the camera because we're going to see Menominee here, we're going to see Chippewa here, and then Eau Claire, the 5, everybody stand up. The 5 shortest people are going to be right behind the chairs. The 5 tallest people are going to be behind them, making sure you don't cover up Menominee. Okay? And then the 5 medium-sized people are going to be sitting on the chairs.
These shoes I'm pretty short.
Go.
Jesus, we have 12 people in this.
Yeah.
It's not rocket science. I mean, if we're close, that's good enough.
It's so weird. Those cameras look like you wouldn't be in that field of view.
A little bit closer there, Paige.
I'm actually good.
Ooh, this is working good. Yep, that's right, Sam. We what?
Like a picture, or what are we doing?
A little bit, Gavin, you gotta move just, and Jess, you gotta move just a little bit so that I can see Menominee, and there you go. That's good. This is the best picture ever, Madeline. Everybody ready? It's got facial recognition, so it's cluing in on. It's got Jake down to and Connor down to and Laura down to It's just perfect. Okay, where's my button? Let's see here.
Aren't you gonna join
record. No, I am not. Everybody's smiling. Connor's not. Probably good enough. Okay, thanks.
Awesome.
That was not so bad, was it, Madeline? It was horrible, she said. Yes, that would be great. Thanks, Madeline. All right. In our books, let's go back to section 1A, and let's continue with our little discussion that we had here. On to function notation. So in our notes, let's write function notation. We wrote this as an equation. Oops, can't see it now. Come on. We wrote this as an equation. Now we're going to write a function. H as a function of t is negative 4.9 t squared plus 20t. One of the things that you need to be disavowed of, one notion that you have that you need to be disavowed of, is that equation, we know you can solve for an equation, right? But that's a very limited use of algebra. Like, for example, we solved for the equation for when the time is 1 second, how high the ball was. Or when the ball was 2 seconds, we saw how high the ball was. That's not very useful information compared to the graph. With the graph, we were able to find every single t and what the height was at that t. So that is function notation. If you notice, what's the one difference in how the two are written between an equation and a function? It only appears on the left side, correct?
Yeah.
What's the big difference on the left side?
H of t.
It's got the variable that's on the right side. Okay? So it tells us we can find the height if what?
We have a value.
We know what t is. Okay? So we can find the height if we know the time. This section right here means height as a function of time is. Actually, I suppose I should highlight the equal sign too, right? You could think of it as a factory, okay? Where I take a certain time and put it into the machine. That's on my input. And at the other end of my machine, out comes a certain height. So when I put the number 1 in for the time, what did I get for the output? How high was it at 1 second? At 2 seconds, 20.4. At 1.5 seconds, it's on your sheet someplace. 18.975 at 2.5 seconds. 19.375, right? So on your sheet, it asks us what does H parentheses 5 mean?
5 seconds.
5 seconds is the time, and the function will tell us how high it is at 5 seconds. Now in this case, I don't know how high it is. We could substitute it in, right? And we could find out. So rewrite all of the phrases that we had up here. So let's do A together. H of one, right? That was letter A, 1 second. And we said that was negative 4.9 times 1 squared plus 20 times 1, which was 15.1. Do B, C, D, E, and F. Compare them to your buddies. Go. I will move my camera, but only because you asked so politely. No, I'd have done it. I'd have done it even if you'd have said, "Hey, dude, get that camera out of the way." I might not have liked you as much as I do now. But I wouldn't have let it cost me major anxiety. Everybody got them? Is it pretty easy?
What are the questions we're asking?
Oh, you can't see the questions. I better put them up there, huh?
Basically.
You can't do both. There. So B, what did you write? H of 2 equals, and just give me the final answer. What did you get for an output for H of 2? 24. C, what did you get? H of
T.
T equals, and then you had to write the whole equation out, right? D, change in height. H of, no, you always do the second one first. H of 2 minus H of 1. If you're looking for change, always do the second one first. Okay, think about it this way. If your checking account has $20 in it, and you write out a check for $10, you would take 20 minus 10, right? So take the second one minus the first one. E, what would you write? H of 2.5 minus H of 1.5. Do you want me to do them on my paper, or do you have it? Anybody need it on my paper? F, H of T2 minus H of T1. On the test, you're going to have things like this, where we would say that's the change, right? And the reason we know it's change, it's that subtract sign between T1 and T2. And remember, it's always the second one minus the first one. So that's a change in height between the second one and the first one. And now, for the really spectacular thing that you can do it's a party trick that you can do to impress people about how mathematical you are, is instead of saying the word change, that's a good math word, symbol. What's the symbol for change?
Subtraction.
Triangle, very good, Sam. It's actually the Greek letter capital delta. So if we make a capital delta, that's the Greek letter D. This is the capital one. The lowercase one looks like that. Kind of looks like a D with a little squiggly on it. That's the lowercase delta. Uppercase delta, lowercase delta. Questions?
Would you write, just pulling numbers out of my head, so like H of 4 delta H of 5?
Yeah, if you were talking about the, if you said H of 4 minus H of 5, that would have been the math for what is the opposite of the change in height between 4 and 5 seconds. Why did I have to say opposite?
Oh, because I did 4 first and not 5.
He said 4 minus 5, and remember, it's always the second one minus the first one, so I had to say the opposite of. On the test that you guys took for intermediate algebra, when you had that division problem, a lot of people had x minus 2 as the denominator, and a lot of other people had 2 minus x as the denominator. Okay, the difference was this one would be subtract, and this one would be add. The numerator changed too, but subtracting is the same as adding the opposite. So if you switch every single sign, you get the same result. I don't know if you remember that question or not. It was on the long division. Okay. I have a hunch a lot of people did it right on MathWay, or did anybody use Photomath for that one? Or just MathWay? Connor, do you remember? No. MathWay. But you understand why I gave you credit regardless of which way you wrote it. As long as you had minus here and plus here. If you got the sign screwed up. Oh, Gavin, there was still one that you didn't do yet. One test. I think so. Check my math lab. Everybody good? Page. One C. In preview 1C, you examined the graph that showed the velocity of two different cars. All right, so we've got another experiment that we're going to do here in our class. Jake, do you want to be the guinea pig again, or would you like somebody else to do it for you? Okay, so what we've got here is we are going to attempt to knock a hole in the wall. That was easy. No, you do not have to walk across these. I'm not sure if I've never used it. Oh yeah, that'll work. Okay, so we've got the same kind of experiment here where we're going to graph a ball. No, this one must not need to be set. We are going to graph a ball that's rolling across those two things, and we're going to see what the graph looks like. I have to save this graph file. Save as the Jakester. RF1 Jake toss. Okay. So Jake, you're going to do it again for us? Yeah. All right, here we go. So he's going to roll the ball from this end to the far, no, start on this end because then we don't have to worry about it crashing into the machine. Okay. Okay. So, just a second here. I think I'm ready. So when you hear it click, you can let her rip. What do you notice is different about this graph compared to the last one for the position? What? It's a straight line. Or, as Sam said, he used a very algebraic word. Say it louder, Sam. Linear. It's linear, okay? So everybody agree that's a very mathematical word, linear. Now, he's going to roll it at a different speed. So I'm going to, let's see if I can do this. I forgot how to do this part. Experiment. Let's see. Store latest run. Okay. Now, he's going to do it at a faster rate, okay? On the graph, how can you tell it's faster? The slope is steeper. But that's not the graph we want to look at. Ignore graph 1, and let's look at this graph down here. Okay, the first thing I'm going to do is I'm going to adjust them so that they are both fit on the graph. Now, I'm kind of disappointed that for some reason it doesn't show this as a straight across. I don't know why that happens. For one thing, the difference between 1 meter per second and 0.5 meter per second is obviously not very perceptible. But the machine is able to do it. So kind of squint your eyes and make stuff up. But if you were to imagine this as being a line, it would go straight across. And this would be a line, it would go straight across. What does the blue one going straight across and the red one going straight across, what's the difference between those two? The blue one is higher, which means it's going faster. So that's the graphs that we're working on page, what page is that? Page 5. So on page 5, that's what we're looking at here, is we're pretending these graphs go straight across. Now I would like you to notice one very subtle difference, or one very subtle thing on our red graph. Maybe you guys can't see it because you don't know what you're looking for.
Shorter but longer.
Do you notice that it's kind of going downhill? What does that mean?
It's starting to slow down.
It's slowing down. Why is it slowing down?
Friction.
Because of friction. Okay, so if I wanted it to stay at the same speed all the way across, I could raise up this end, right? If I raised up this end a little bit and let her rip, it's possible that it'll, I don't know, I'm just guessing here. It's possible it won't. Jake, you're going to need some help here. Connor, can you hold this steady? Oops, don't push that. Let's give it another shot and roll slowly, okay?
Okay.
Just wait. Oops. I lost my second one. Okay, so if you notice what happened instead of it going straight across, it actually sped up. So what should I do instead of that book there?
Get a thinner book.
Have a thinner book, right? So I've got some adjusting to do. Okay, page. File. Save as. Constant speed. So let's look in our books at this graph at the bottom of page 5. Jordan and Renee leave Cafe Olay in separate cars, enter the interstate at the same time. Parents or insurance companies sometimes use apps to monitor a car's speed. Suppose such an app produced the following graph showing the speed of each car for the first 30 minutes they were on the interstate. So I did this graph in Desmos. Let's see if I can find it here. I'll show it to you. So here's the graph in Desmos, and if you just pay attention to the first 30 minutes, so up until right there, if you just pay attention to the first 30 minutes, you notice that Renee and Jordan are both going along. So we've got this graph right here, page 6. Use the function notation from lesson 1. Let v of t be the velocity of Jordan's car, d of t being the distance of Jordan's car. A of t is the acceleration. What does acceleration mean? Speeding up or slowing down or changing velocity. There are 3 pieces of equipment in a car that change velocity or that cause acceleration. Anybody know what those 3 pieces of equipment are? You want your car to speed up?
Gas
pedal. Now, acceleration can be negative. So what's another one? Brake. And then the third one is kind of hinky. I'm not so sure that I like this one. But the steering wheel also causes acceleration because it changes not the speed, it changes the direction. So those are the 3 instruments of acceleration. Think about it this way. If you had your eyes closed, acceleration is what you feel happening. So if you feel going like this, what did the driver of the car do? Brake. Now, obviously, it better not be you because you shouldn't drive with your eyes closed. Okay? If you go like this, what did the driver do? And then if you go like this, what did the driver do? Okay, so guys, actually, this is more for the girls. So if you're in a car that doesn't have bucket seats, that's the important thing. And you feel like you want to get closer together. When you go around a corner, when you go around a right corner, you kind of like scooch closer. Okay, you just, oh, the seat is so slippery. Okay? Guys, we call that opportunity corner. All right, here we go. Compute the following quantities. So we're going to make a table. V0, V.25, V.5. We're going to give those 3 values. Then we're going to do the same thing for D0, D.25, and D.5. And then we're going to do A of 0, A of 0.25, A of 0.5. Now the important thing is that it says here, we are going to be doing this for Jordan. So if you look at the graph here, we're talking about Jordan, the solid line. Okay, go. Fill out that table. Work with the people at your table. Do those numbers make sense that I put down? You know how to fill in the missing numbers.
Use that graph.
And remember what I said the definition of acceleration is? If you close your eyes, what are you feeling? Jordan is driving at 60, and then at 60, and then at 60. So if you have your eyes closed, what are you noticing? Anybody put down a number for acceleration? No. Very good. The acceleration at 0 was 0. The acceleration at 0.25 was 0. The acceleration at 5 or 0.5 was 0. Does that make sense? She never speeded up. She never slowed down. Okay? Then it says, number 3, write formulas. V of t equals d of t equals a of t equals. So, for v of t, remember, this is a machine. So I'm going to put 0, I'm going to put any time, no matter what time I put, I'm going to put it into this machine. For velocity, what am I going to get out over here for Jordan?
60.
When you put it in 0, what did you get?
60.
60. When you put in 0.25, what did you get? When you put in 0.5, what did you get? Okay, so when you become a mom, it is important to know the function for any question that your kids ask you is, Mom, can I? What is your standard response? No. Okay? You will raise kids that will be as contrary as you are if you do that. Your answer should always be yes. Mom, can I jump off the bridge? Yes, dear, you may. So, what's our V of t? Our standard response, no matter what the question is?
60.
How about for A of t? What's our standard response?
0.
For distance, what did I do in each case?
Multiplied 60 by
Multiplied the time by what?
the distance, or by the velocity.
Velocity. So our answer is always going to be 60t. What is the difference between the first one and the second one, between V of t and D of t? They both say 60. Yeah.
One's how fast they're going, the other one is how far they
But what's the difference in the formula? One's how fast they're going, the other one's how far they're going. Would you agree that how far they're going changes, right? Everybody agree with that? How did you find how far they went? By what mathematical process? Multiplication, right? What did you multiply? The speed times the time, right? 60 times the time. Next. So now, after another 30 minutes, the app has updated. It now has the data for an entire hour. And here's what it says. What do you see happening to Renee's speed over the whole hour? Stays the same. Did Jordan stay the same?
No.
No. At a half an hour, what did Jordan start doing? Accelerating. So now she better have an acceleration when we answer these questions, right? Number 4, 5, and 6. Answer those questions. In your group, go. Question 4, what's the answer?
No. Yes.
At least during the first hour. If things continue, Possibly. We don't know what Renee or Jordan is going to do. It appears as though Renee is kind of stuck on this 70 miles an hour business. Jordan, she's been kind of erratic, slightly erratic, right? For half an hour she went at the same speed, and then she said, enough of this business. Number 5, I would like to show you on your sheets. On a velocity graph, distance is the area under the line. So I'm going to shade here for this is how far Jordan drove. Does everybody agree? It's all of the area underneath that line. Now, if we were talking about finding that area, this is 0.5 hours. This is 60 miles per hour. What is the area of that? What is the length times width of that? 30. So she went 30 miles here. Is there anybody in the studio audience that knows what the area of this part here is? Well, think about it as being a triangle plus a rectangle. What's the area of this rectangle down here?
30.
30? Everybody agree? But the area of the triangle, would you agree this is 10 miles per hour? For a half an hour, what's the area of this part right here?
5.
Close. Remember, it's a triangle.
Oh, yeah. 2.5.
Isn't it times together and divide by 2?
Times together and divide by 2. Did you say 0.5?
2.5.
2 point. I thought I just heard 0.5. So that's 2.5 miles. So how far did Jordan travel altogether? 62.5 miles. Everybody agree with that? Okay. But the question asks, could Jordan have caught up with Renee according to our graph? Do you notice something that's true about Renee right here? This is the more that Renee drove, correct? If you're talking about the area under a curve, that's the amount more she drove. How much did Renee drive altogether? 70 times 1, right? So how much is this more area that she drove? 7.5 miles. Does that make sense? Because she drove 70 for a whole hour. How far? 70 miles. Last thing. What does that last question ask? After 1 hour, the graphs come together. It does not mean those two cars met. What does it mean? At that time, they are going the exact same speed. We'll start there tomorrow. Here's the situation. Wednesday and Thursday this week, I will be at a conference. Next Monday, I will be fishing. We will not have class after tomorrow, until next week, Tuesday. Okay? Get into my math lab. Start working on it ASAP so that you have questions for me